Hi, everyone. My name's Ollie Williams, and I'm a software engineer on the Xbox One team based in Stratford-upon-Avon in the UK. And today, I'll be talking about how to bring your Unity game to console, as well as some tips and tricks to help you along on Xbox One, PS4, and Nintendo Switch. So I'd like to start off with a little show of hands. So who has never shipped a console title with Unity before? Pretty much everyone. Who has? Okay, we got a couple. Okay. And who's shipped any console titles in the past not with Unity? Okay, cool, great. Well, hopefully we should have something for everyone today. So let's have a look at what we've got lined up. So first, we'll look at the incentives and what they are for porting your games to consoles at all. Then we'll look at how to register with the console platform holders and how to get your development environment set up. We'll look at how to develop and iterate on consoles with details on how to squeeze performance out of the hardware and how to implement console-specific features. Finally, we'll look at some tips and tricks that will be useful to bear in mind as you develop and port your game. So to start off with, the first question we should answer is, why should you port your game to consoles at all? Well, hopefully I can convince you today that it's very easy to get started. But first, let's look at the incentives. We're at a very mature stage in this console generation, with big successes across all three consoles. Worldwide console hardware sales are now at over 175 million units. And there are an estimated 200 million console users in the world today. Now, that's quite a broad market to appeal to. But you might be wondering, don't people only buy consoles to play first-party games? Well, to quote Unity CEO John Riccitiello from last year, about a little over half of all the games built for Nintendo's platforms are built in Unity. A little bit less than that for Xbox and Sony, but in aggregate, it's more than half. And isn't that great? So part of the reason for this is that as of this console generation, self-publishing indie games on console platforms has become much easier. And here are some examples of great Unity games that have been published or are due to be published on consoles. I think you'll recognize a lot of the games on here, from Beat Saber, Ori and the Blind Forest, Yooka-Laylee. There are games of so many genres from so many different kinds of studios. So with that being the case, why does it sometimes seem a bit scary or difficult to develop for consoles? Well, if you simply Google your console-related questions for Unity, you won't find any relevant results. And the reason for this is non-disclosure agreements, or NDAs. When you register to develop for consoles, you'll need to make such an agreement with the relevant platform holder, and that's Microsoft, Sony, or Nintendo. Amongst other things, this means that you can't talk publicly about console development. So for the same reason, there are certain details that I won't be able to talk about today, and please bear with me if I can't answer some of your questions. Well, let's start at the beginning. To get under the right NDA and to develop with Unity on consoles, you'll need to register with the relevant platform holder first. I'll run you through how to sign up as an indie developer. If you have a publisher, it's worth asking them first, as they may already have an existing relationship with the platform holders. So before I get to any specific platforms, I should point out that all of this information is available on the Unity website at unity3d.com/unity/features/multi-platform, which has details for registering to develop for all our compatible platforms. For Xbox One, you can sign up to the ID at Xbox program at xbox.com/ID. This allows anyone to apply to self-publish their games. And this is not to be confused with the Xbox Live Creators program, which allows you to quickly build and publish games for Xbox One with UWP. The advantage of ID at Xbox is that you'll have access to more features, such as achievements and online multiplayer. There are more details about the differences at this link. It's completely free to register with ID at Xbox. Once you're accepted into the program, you can develop using your current Unity license, or else you can receive a free Unity Pro license for Xbox One development from Microsoft. Through the ID at Xbox program, Microsoft will also send you 2 dev kits for free. For PS4, head to partners.playstation.net to sign up as a PlayStation developer for free. You must register yourself or your company with Sony, providing some information on who you are, either as a company or a sole trader. You'll also need a static IP address to access Sony's development portals, and a non-public domain email address along the lines of @your web domain, so no Gmail, Outlook, etc. And once you're registered, you'll be able to purchase dev kits and have access to Sony's developer network, where you'll find the SDK, software and samples, and access to their support services. You'll also get access to a dedicated Unity forum, where you'll find all the Unity releases, samples, and support. Developing for PS4 using Unity is free. You'll get a license key from Sony to use in your Unity editor once you register with them. And for Nintendo Switch, head to developer.nintendo.com to sign up as a Nintendo developer. Once signed up as a Nintendo developer, you can then apply for Switch development. The Unity for Nintendo Switch extension is free for registered Nintendo developers, and all the details on acquiring hardware and software will be available to you on the Nintendo Developer Portal, or NDP. You can either develop using your existing Unity subscription, or else you can use a free Unity Pro license for Nintendo Switch development only. So, once you've signed up, what else do you need to get started with console development on Unity? Let's take a look. As for Unity itself, all consoles are supported on all current versions of Unity, and this has been the case since about Unity 5. As of right now, the live versions are the recently released Unity 2019.2, as well as our 2 long-term support branches, 2018.4 and 2017.4. Each version of Unity is built with a particular version of the relevant console SDK, which you can download from the relevant platform holder once you've registered. It's important that you pair them together appropriately, and each release of Unity will tell you which version you need. The console SDKs are upgraded periodically by the platform holders, at which point we upgrade all current Unity versions to use the latest one, including those in LTS. So for which version of Unity to pick, you should be able to start developing with whatever Unity version you're already using. Then, as you get ready for submission, we strongly recommend that you move to the relevant LTS branch. This way, you can benefit from the stability of those releases while still getting critical bug fixes and SDK upgrades. So you can see our support cycle on this graph. If your project is running on an old version of Unity, you can upgrade to 2017.4, and you'll still have until early next year to submit your game before Unity's long-term support expires. If you're using a 2018 version of Unity, then you'll have until early 2020 to submit with Unity 2018.4. And if you're just getting started with your project, we suggest that you start with Unity 2019.2, and then you'll have the choice later of whether to upgrade to the 2019 LTS or whether to upgrade to Unity 2020.1. In terms of other requirements for console development, you'll need the following: a Windows 10 PC with Visual Studio installed. You won't be able to use macOS or Linux. You'll need the relevant console SDKs and other software tools, and these will be available from the relevant platform holders once you've registered. Similarly, you'll need to get the relevant dev kits from the platform holders and hook them up to your dev PC. And for some platforms, you may need to have a static IP address to be whitelisted for certain services, or register a domain name, or register as a company. Again, detailed requirements for each platform will be provided as you register. Great. Now you're registered, you've set up your dev environment, you've got your dev kits. It's time to start developing your game on console. Let's dig into the development cycle. So we have our Unity project ready, as well as our dev kit hardware. The first question is, How can we build and deploy a game to our shiny new dev kit? The answer is that there is a Unity editor extension for each console. These extensions tell Unity how to build your scenes and other assets of the console, as well as allowing you to deploy your game to run it on a dev kit. You simply switch targets and hit build and run, and that's it. If you've built mobile games before, then this workflow will probably be fairly familiar to you. So the great thing is that, like any platform, your game will just run on each console, thanks to the magic of Unity. However, we're not done yet. The most important thing is to remember that running your game in the Unity editor is not the same as running it on real console hardware. Your development PC has different specs to each of the consoles, and the consoles have different specs from one another. There are many ways that they differ, including clock speeds, how quickly they can save and load, and what kind of memory is available. These differences can get complex, but here's a simple graph that illustrates my point. The total amount on of RAM on each console varies considerably. Like you've got the 4 gig on the Nintendo Switch, all the way up to 12 gig on the Xbox One X. Again, the full list of differences between consoles is long, but I hope you can appreciate the range of specs that you'll be dealing with. Those of you with powerful development PCs should also recognize how the console specs, how different they are to your own hardware. So how does this affect you as a Unity developer? Again, our goal at Unity is to provide the magic that makes sure that your games just work out of the box. What you will have to do is appreciate and allow for the differences in performance and other behavior. So let's look at development strategies. It's not a good idea to make your whole game in the editor and then try and port to consoles at the last minute. The strategy we recommend is to run your game as frequently as possible on the dev kits throughout game development. In particular, make sure to test the lowest available specs. And by that I mean the Xbox One as opposed to the Xbox One X, PS4 as opposed to PS4 Pro, and the Nintendo Switch handheld mode as opposed to docked. So the good news is that Unity's debugging and profiling tools work, even when your game is running on a dev kit, including the profiler window, console log, frame debugger, script debugging, and more. All of this makes testing and iterating on consoles builds quick and easy, with workflows that you'll already be familiar with from the editor and other platforms. We'll get onto profiling in a moment, but now let's look at an example of running a game on console and debugging a problem that we find there. So, we start from the Unity editor, and this is the universal render pipeline demo that comes as a template for all new Unity projects with a couple of modifications. Now we're going to run it on a console. In this instance, we'll go for Xbox One. We have the Xbox One extension installed, so once we're ready to build, we simply switch targets to the Xbox One, which will prepare our environment. And then we'll hit build and run. And Unity will now build all the assets and compile all the scripts for our game. It will then arrange all the resulting files for us and then deploy everything that we need to our connected Xbox One dev kit. Let's look at what our dev kit is displaying, and that doesn't look right. The camera's spinning around the wrong axis, and there's a wooden plank that's turned blue. Of course, we could try and fix this in the Unity editor and rebuild and redeploy, but wouldn't it be easier if we could debug this while our game is running on the kit? Let's start script debugging. Back on the development PC, we'll open our C# project in Visual Studio. We'll then use our Unity extension tools to connect the Manage Debugger directly to the Xbox One dev kit using its IP address. Once we're connected, we'll put a breakpoint on the script code that's causing the problem. Once it breaks, execution pauses on the dev kit, and we can now look at these variables in the watch window. We can see that the rotation axis around the x-axis when it should be the y-axis, so let's change that. We can also see, if we open up that plank color, that it's set to blue, so let's change that to a nice wood color. Now let's remove that breakpoint and continue execution. Back on the Xbox One dev kit, we can see that the values we changed have updated in our game even while it was still running. That looks good to me, so let's make those changes permanent. Back in Visual Studio, we'll make the changes to the script, and then we can rebuild and redeploy from the Unity editor. And if we only make changes to the scripts, we can also do a scripts-only build, which dramatically speeds up the build time as it doesn't need to build any of the other assets. And there we are. So, of course, this is only a small and fairly contrived example, but I hope you can see the power of the tools and workflows that Unity provides. And as a quick aside here, who went to the keynote yesterday? When we head to the keynote? Good, that's what I like to see. You'll notice that we're starting on a thing called Unity Live Link. So as we move to a more data-oriented tech stack, with data-driven design, we'll be able to just push data directly to a running player. So what I just showed you is what we already have with the tools that's available to you right now with Unity, and this will only get better as Unity Live Link becomes available to you. So, we've seen how to run our game on a dev kit. We've seen that the hardware will behave differently to our workstation PC. So we need to be able to make sure that we can optimize and ensure we're getting the best performance out of the console hardware. It's always important to profile first before doing any optimizations. This is key because you don't want to spend time rewriting code that doesn't actually solve any performance problem. Now, if you want your game to run at, say, 60 FPS, then that means that each frame has to be ready to go within, of course, a 60th of a second, or about 17 milliseconds. If your frames are taking longer than that, the first thing you want to do is determine what you're being bound by, i.e. what's pushing that frame time the most. Broadly speaking, the two most common areas are either the CPU or the GPU. If you're bound by the CPU, it could be related to your script code, disk reads, UI layout rebuilds, or even physics if you're relying heavily on that. And if you're bound by the GPU, you'll want to understand what part of the graphics pipeline is causing the bottleneck, which could be any number of things, for example, particles or post-processing effects. But how do we work this out? Let's look at two different ways of profiling. The first is to use Unity normal profiling tools, which work across all consoles. And this is what it looks like. You're probably all familiar with it during your work in the editor. And just like the script debugging demo I showed you earlier, you can attach the CPU profiler directly to your console dev kit and analyze your frames just as you would in the editor. This way, you can see how much time your code is taking, and you can find any CPU spikes and fix them. You can also see how many garbage collected allocations your scripts are making. Keeping track of these allocations is important for keeping your memory footprint under control, as well as for avoiding CPU spikes when the garbage collector runs. You can also access the more advanced features of the Unity profiler, like deep profiling and profiler markers. And what deep profiling does is to profile every line of code, making it pretty useful to find those hard-to-find allocations. As you can imagine, due to the sheer volume of data that it needs to collect, deep profiling is often really slow. So we only recommend using it in isolated areas, for example, when you're trying to analyze performance spikes. And if deep profiling is too slow, you have another alternative, which is using custom profile markers. All it requires is placing profiler.beginSample and endSample to logically group any part of your script code, typically in suspect areas. You can even nest them to give you a better idea of what's going on in your game. You'll just have to make sure that every begin sample has a matching end sample. And once you've done that, the sample name that you use will appear in the Unity profiler, allowing you to see the exact timing of that block, as well as view any allocation within it, And again, you don't need to use deep profiling to use these custom profiler markers. And because the profiler markers get compiled out of release builds, you don't have to worry about removing them later on. So the second way that we can profile is to use the native profilers. Each platform provides their own profiling tools that allow you to dig into more hardware-specific details. For example, you can see exactly what each CPU core is doing at any particular point, or how the GPU constructed an individual frame. For today, we'll look at just one as an example. So let's look at PIX, which is the native profiling tool for Xbox One. PIX stands for Performance Investigator for Xbox, and it's really a collection of multiple profilers focusing on different areas. This tool provides a high-level overview of the CPU and GPU usage of your title and allows you to dig into a lot of detail as to how your game performs. So the Xbox One version of this tool is under NDA, so I'll only show a brief look today. The good news is that there's also a version of PIX available for analyzing Windows games, and that version is publicly available, so you can go away and try that today. So, since we've already looked at CPU profiling with the Unity's tools, for PIX today, we'll focus on its GPU capture feature. To analyze a GPU frame on Xbox One, you'll need to have your dev kit connected to your workstation PC with the Xbox One version of PIX installed. And here's what it looks like when you take a GPU capture. This screen contains all sorts of information on exactly how a single GPU frame was constructed. As you can see from the screenshot, this is actually a frame from the Forest demo that we showed at Unite last year. And down at the bottom here is a timeline that lays out the exact order of how the frame was constructed and provides timings on how long each instruction took. That's quite a lot of information, but if we zoom into the timeline, we'll be able to see the detail of each step and identify any sections that are taking too long. As an example, if we zoom into this part of the timeline, we can see that reflections took about 5 to 6 milliseconds of our frame. So maybe there's something that we should optimize here to try and reduce the frame time. There are more PIX features that we could use to dig into the detail of why these reflections are taking so long. And we could also just try reducing the quality of these reflections in the editor and rebuild, take another capture, see how we get on. So, our game happily runs on consoles, and we've carefully profiled and tweaked our game content to get the best out of the console hardware. Now, there are a handful of console-specific features that you may want to implement. So next, let's look at how to do that. In order to give you access to platform-specific native APIs, we provide a set of plugins that allows you to interface with this functionality directly from your C# scripts. Using our native plugins, you can easily add support for features that are specific to consoles. For example, consoles generally run in a multi-user environment, so the plugins provide tools to deal with user management, unlocking their achievements and managing their save games. They also provide functionality for running online multiplayer. So these plugins come with their own documentation to help you along, as well as their own source code. So while we strive to add any functionality that you could need for your game, it's occasionally useful to be able to dig down into the source code and expose any other native functionality that you need, and then you can run it from your C# scripts. So, as an example, let's look at unlocking achievements, which are available on Xbox One and PS4. So I think every Xbox One gamer will be familiar with this little pop-up animation. It appears when you unlock an achievement in the game. So in order to trigger the unlocking of the achievement, and also in order to control the way the pop-up notification is displayed, you need to call Xbox One or PS4 specific APIs. The native plugins allow you to easily do that from your C# script code. So once the player has done something cool, the script code to run looks like this on Xbox One. You just need to get a hold of the current user playing the game, and then maybe customize where on the screen the pop-up will be displayed. You know, maybe you want to stop it from distracting from gameplay, for example. And then with one simple call, you can unlock the correct achievement for your player. The native plugins not only expose native APIs so they can use from script code, but they also provide interfaces between certain console features and certain Unity features. As you can see in this diagram, the plugins themselves sit at the boundary of managed C# and native C++ code, calling into the relevant console SDK directly. In fact, our native plugins come as a set of pairs of native and managed libraries, so that all you have to do in order to use them is copy these libraries into your project's plugins folder. So, the last thing I'd like to talk about today is tips and tricks. And by that I mean the things that you'll want to keep in mind as you're developing your game before or during the time that you're porting to consoles. These are the sorts of areas that you might trip over on consoles if you make certain assumptions or use certain features in certain ways. So the first tip I wanted to share is about organizing your game content. When you're building a game for consoles, there's 2 points that you need to be mindful of. The first is that you may want to have platform-dependent content. For example, you could have very high-resolution textures for 4K rendering that wouldn't be needed for lower screen resolutions. Perhaps you would also need different sprite sheets for different consoles' button mappings. You would also only want to ship the native plugin libraries on their relevant platforms. And splitting up your content this way allows you to have a smaller install size for your players, with less wasted space for content that you won't be using. The second is that you'll probably want to patch your game content at some point. Maybe you'll be fixing bugs or adding new content. Your game content needs to be arranged to allow for sensibly sized patches to be applied. The last thing you would want is for your users to have to re-download most or all of your game when you've only made a minor change. So first, let's look at a very common way of arranging game content, which is using the special resources folder. And to quote from the Unity documentation page on resources, best practices for the resource system: don't use it. Improper use of resources folders will increase application startup times and the length of builds. The resources system degrades a project's ability to deliver custom content to specific platforms and eliminates the possibility of incremental content upgrades. So, as you can see, that is anathema to the 2 points we've just discussed. So we do need something better than that, so please don't be seduced by how simple it is to use resources. So what we do recommend instead are asset bundles, which allow you to bundle various assets into files so that if you only change a small number of assets, your game patch will then be much smaller. Of course, you could put each scene into an asset bundle, but this means that any changes to that scene will likely incur a patch for the whole scene. And that's almost guaranteed if you then compress the asset bundle. So the way that we do suggest that you bundle your assets is to make appropriate bundles of the right size and granularity. Of course, what proper granularity means will depend on the type of game and the type of content that you're dealing with. So please see the Unity tutorial on asset bundles to find out more about the best practices there. Looking forward, we have a new way of dealing with asset bundles, which is addressables. This combines the simplicity of resources and the freedom of asset bundle. It provides a layer of management of which assets will go into which bundles and where those bundles will end up. There's a talk tomorrow at 4, I think it's in C1M1. So if you want to learn more about addressables, then I suggest that you attend that if you want to learn more. So the next thing you want to be aware of is that consoles require the IL2CPP scripting backend. You may already be familiar with this, but it goes as follows. First, your C# script code is compiled using Microsoft's Roslyn compiler into intermediate language code. Then, our IL2CPP converter translates this intermediate language output into native C++ code. And then that is compiled using each platform's C++ compiler into a native library that our player imports and executes. So what this means is that resources aren't used to interpret your code at runtime. It's all already compiled, ready for the CPU to execute directly, and this ensures the best performance. However, this comes with a bit of a gotcha, which is that you can only perform ahead-of-time compilation, as all the code must be compiled and ready at runtime. This means that certain C# coding patterns that rely on just-in-time compilation, or JIT, simply won't work. The most common examples of this are found in places that require runtime code generation, such as in the reflection library and in the special dynamic type. Historically, we've most often seen people fall afoul of this constraint while trying to perform serialization, though there are AOT-friendly ways of doing that. We also recommend that you watch out for asset store packages that haven't been tested on consoles, since they may be inadvertently using these coding tricks. So, the last thing I wanted to talk about today is that each platform has a set of submission requirements. This is essentially a checklist of things that your game must comply with in order to be published. They vary per platform, but generally include requirements for reliability and performance. So basically, your game has to run well and not crash a lot. So there are certain kinds of things that your game must and mustn't do as well. Again, this varies per platform, but imagine that your player just signs out in the middle of playing your game and somebody else signs in. You'll have to deal with that appropriately, and what appropriately means will depend on what your game is doing at that time. So, the submission requirements for each platform will be available as soon as you sign up to the relevant platform holder. We strongly recommend that you read them thoroughly before you start porting your game, and keep them in mind all throughout game development. So, earlier I told you that there is certain console-specific functionality that you may want to implement using the native plugins. Here I'd like to go one step further and say that there's certain functionality that must be implemented with the native plugins, instead of the normal Unity methods. There is some Unity functionality that won't work on consoles at all, and there is some functionality that has to be done a certain way to comply with submission requirements. And again, these vary per platform. I won't go into too much detail, and there is documentation to follow once you sign up. One quick example I will mention, though, is using the player prefs API. On PC, it's very common to use player prefs as a quick and easy way of saving the game to a file on disk. However, since consoles generally run the multi-user environment and support cloud saving, this approach won't work, and you'll need to use the corresponding plugin to save the game instead. So the recommended way to deal with this is to use scripts to create a save manager that can save and load appropriately per platform. Of course, you can also create similar managers for achievements and other functionality. Finally, we've spoken a lot about performance, which is key to your success on consoles. One final tip is that once published, your game has to run on all hardware variants. For example, when you've finished and published the Xbox One version of your game, it will have to run on Xbox One, Xbox One S, and Xbox One X. Similarly, the PS4 has the PS4 and the PS4 Pro, while the Nintendo Switch has different performance characteristics in handheld and docked mode. The easiest way to deal with this is to detect exactly which hardware you're running on, which can be done at runtime, and scale your resolution and quality settings accordingly. This is why we suggest frequently profiling on the lowest available variant, so you can understand the baseline performance and author your content accordingly. So, let's recap what we've looked at today. First, I hope I've convinced you that console development with Unity isn't scary. All you need to do is register with the console platform holders, get your hardware and software set up, then test with it frequently. This way, you can profile and optimize your game for the hardware and add console-specific functionality with plugins. Lastly, always keep the submission requirements in mind as you develop. And I'm finished. Thank you for your time. Do we have any questions? Don't all shout at once. Yeah?
You said that you need a Windows 10 PC. Is that correct? All the three platforms?
Yes. So the question is, do you actually definitely need a Windows 10 PC? And the answer is yes. And also Visual Studio, yes. You can use whatever you like for editing your code, but there are certain tools that you'll need Visual Studio for, yeah. Any other questions? Sorry? Oh, yes, definitely. So the question is, will the consoles benefit from the burst compiler? And the answer is yes, definitely. Obviously, the consoles are multi-core machines, and as with any Unity game on any platform, the traditional way it would have been done is having everything on the main thread. So you just have this one core running your main thread and all the other cores doing nothing at all. But burst will take advantage of all the cores. So yeah, great question. As a university student, well, I think you'd probably just go through the same route as you would go for signing up as an indie developer. I don't know if there's any particular special thing for students.
No, you have to buy it.
This gentleman says you have to buy it. Yeah.
Are there any plans to facilitate downloading the console-specific plugins of Unity through the Unity Hub, for example, instead of through each of the consoles?
Yeah, watch this space on that. Any more questions? Yes.
Once you have approval for a certain project, are you locked into that project, or can you change and make a different game?
The question is, once you start on a project, are you locked into that project? I think that will come down to your relationship with the platform holder. So I think you'd have to ask them on a case-by-case basis. Anything else?
Is there any plan for Unity to support that, to provide those managers for saving and handling users and machines built into Unity instead of having to write those?
Again, watch this space. Oh yeah, so I've just realized on the desk in front of me, I should have probably noticed this. This is actually an Xbox One X dev kit. So it comes with extra hardware that you wouldn't find in a normal console, of course. It also comes with these nice little buttons and lights and a little screen on the front so you can actually draw anything you like to it, any special debug information that you'd like to just have at hand at any time. I thought that was quite cool. Yeah. So it comes with a lot of sort of pre-built ones, so you'll get things like FPS counter out the box, and you can also do any custom debug information you like. Any more questions? Yeah? Yeah. Sorry, it's supported on? Yeah. Is the question, is HDRP going to be supported? The answer is yes. Yes, HDRP is supported on... I don't believe it's supported on Nintendo Switch. You use Universal Render Pipeline for all our platforms. Yeah?
Hello. Yesterday, during the keynote, and also here, you showed an example. So, live link, we can change values regarding, for instance, transforms, materials, shaders,
Yeah.
and here, you showed an example where during runtime, you change the value of a variable.
Yeah.
Is there any plans, or is it already available, if you are aware, doing the same but with logic? So if I change the logic on the script, can it hot swap compatible code?
So no, the answer is yeah. No, not really. It's entirely based around data at the minute, yeah. Probably got time for one more question, yeah? No, that's not necessary. I mean, like with any platforms, you can install everything on one machine. And then, so when you want to build for Xbox One, like I showed you with the build window, you just switch targets to Xbox One and build and run. If you then want to build for Switch, switch to Switch, build and run. So yeah, you don't need to like separate out anything. As long as you've authored your game in a way that allows for platform-dependent compilation, then it should be fine. Yeah? What do you mean fast? Yeah, no, we don't have any way of doing that. Any more for any more? Okay, I think then we're done. Thank you very much, everyone.